3, it's getting multiplied by 4, so 1 would be the common difference. All right, consider the arithmetic sequence A, where A of 1 equals 5 and D equals 3. What is the 10th term of the sequence? So we know the first term is 5. And if I want to build this sequence from the previous term, the common difference means we're going to add 3 to the next term. So I could figure out the 10th term by adding first, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. So the 10th term would be 32. If we think about how we can get there a little bit more of a streamlined way, what we're doing over and over again is we're adding 3. All right, so we're adding 3. Now the question is, how many times did we add 3 to the original 5 to get to the 10th term? We added 3 once, twice, 3, 4, 5, 6, 7, 8, 9 times. So if you think about kind of an easier way of doing this, we're starting with 5 and we're adding 3 9 times. 3 times 9 would be 27, and 5 plus 27 is 32. So we could do the same list for the 20th term. But again, I want to kind of use the pattern to our advantage here. I know I'm going to start at 5, and I'm going to add 3. The question is, how many times am I going to add 3? So since we're starting at 5, and that's our first term, and we want to get to the 20th term, we're going to add 3 19 times. So 5 plus 57 would be 62. If I continued the list, (11, 12, 13, 14, 15, 16, 17, 18, 19, 20, we see that we do get to 62. So the list is going to be a little bit tough when we get to the higher number of sequences or higher terms, but we can use that kind of shortcut to get there. And that leads us to what the other way of expressing sequences is, and that's using an explicit formula. It's going to be an equation. All right, so the equation is going to build kind of from the linear equations or the exponential equations. And we started a little bit of review with that earlier. So we are going to start at 5, and we're going to add 3, not n times, n is the term we're looking for, but n minus 1 times. And if we want to simplify that, we can distribute that 3 and we get 3n plus 2. So either 5 plus 3 times the quantity n minus 1 or 3n plus 2, either one of those would work. All right, so consider the arithmetic sequence defined by the recursive formula below. F of 1 equals 3. F of n equals f of n minus 1 plus 9. So if you think about what we're looking at here, the next term is equal to the previous term plus 9. So 3, 12, 21, 30. Those would be our first 4 terms. The explicit formula to get the nth term, we're going to start at 3, and we're going to add 9 n minus 1 times. So we can have 3 plus 9 times n minus 1, or 9n minus 6. So if you figure out the 8th term, we get 66. If I use the non-simplified, we get 66. And if I continue with the pattern just to check, 5th term, 6th term, 7th term, 8th term. All right, consider the arithmetic sequence defined by the explicit formula below. F of n equals negative 4n plus 19. The first term, we would get that just by plugging in 1, just like if it was regular function. So the first term was 15. The second term equals 11. So our first term is 15, 11. The next term would be 7, 3, negative 1. So our numbers are going down by 4. So if we want to define this by a recursive formula, our first term is 15. We get the next term by taking the previous term and subtracting 4, or adding negative 4. So just be careful when they give you an explicit formula, because remember, this is the first term, 25, and that is going to be f of 1 or a of 1. So if you look at this formula, 25, 22, 19, 16, we know the numbers are going down by 3. So if we're looking at a explicit formula, we're going to start at 3, and we're going to subtract we're going to start at 25. We're going to subtract 3 n minus 1 times. And if we do a little simplifying, we get negative 3n plus 28. So just to check, I would plug this formula in my calculator, just like we always do with y equals. And again, I want to make sure I look at the first term is 25. So not 0, but 1 for the x, the y is 25. And then 22, 19, 16. So that formula matches our sequence. All right, so looking at geometric sequences, we have our recursive definition. G of 1, the first term is 5, and r is 2. The common ratio is 2. So if we start with the first term, we're going to get the second term by multiplying by 2. So if I keep going looking for the 10th term, it's like 2,560. Again, these numbers are getting fairly large, and working this way is just a little bit redundant. So if I start off with 5, I'm going to multiply by 2 over and over again. And how many times am I multiplying by 2? I'm multiplying by n minus 1 times. So in this case, I'm multiplying 2 to the 9th power. So if I put that in, we do get 2,560. Just a lot quicker of a way. So if the 20th term, if I start with 5, I'm going to multiply 2 to the 19th power. So we get 2,621,440. So similar to the arithmetic sequences, our explicit formula is going to have n minus 1. This time it's going to be our exponent. So if we're starting with g of 5, or sorry, first term being 5, g of n is going to have the starting value at 5 multiplied by the common ratio raised to the n minus 1 power. So if we look at another geometric sequence, f of 1 equals 3, our first term is 3, and the recursive formula tells us that we're going to take the previous term and multiply by 4. Our first 4 terms would be 3, 12, 48, and 192. Our explicit formula is going to start at 3, and we're going to multiply by 4 n minus 1 times. So the fifth term is going to be 3 times 4 to the 4th power. And we get 768. Before I move on from this, I just want to put that in my calculator and look. If I type in 3 times 4 raised to the x minus 1, first term is 3, 12, 48, 192, 768. So they match up with the terms we talked about, the first 4 terms and then the fifth. Consider this should say geometric sequence. Defined by the explicit formula below. F of n equals 8 times the 3 raised to the power n minus 1. Determine f of 1. Now, as we get more comfortable, we're going to be able to pick out f of 1 faster. All right, but I just want to go through the process here. If I plug in 1 for n, 1 minus 1 is 0. And anything to the 0 power is equal to 1. So 8 times 1 is 8. And that's showing up in the equation. That's our first term. f of 2 we get 3 to the first power, so 8 times 3 is 24. And that makes sense because our common ratio is 3, so our first term is 8, the next term is 24, multiplying by 3, 72, and so on. All right, so which explicit formula defines the sequence 64, 16, 4, and 1? So if you're looking at these, the first term is 64. So that's what I should look for. And then I want to look at what the common ratio is. It's going from 64 to 16 to 4 to 1. What's happening to those numbers is they're getting multiplied by 1/4. So 1/4 shows up in 3 and 1. So what's the correct answer? Since we're looking at our first term, we're looking at n minus 1. So 3 is going to be the correct choice. But as always, I would recommend going to your calculator and just making sure. So if I type in 64 times 1/4 to the x minus 1, first term is 64, 16, 4, 1, and so on. All right, so on the next 2 pages, there's some questions about sequences. I want you to try to answer those questions, all right, and then restart the video and check your answers. All right, so for the first one, it's asking for a recursive formula. So they're kind of testing to see whether you know whether the formula is recursive or explicit. So the explicit formulas are 1 and 2, so those are out. So it's a question, is it 3 or 4? So our first term is 3, and each term goes up by 2, so choice 3 is the correct answer. The next one, they're asking for the explicit formula. Each term is going up by 4, and the first term is 12. So I plugged those in, and I figured out the equation is 4n plus 8. As always, I would recommend just double checking. First term is 12, 16, 20. Those match up. Top of the next page, -6, -10, -14, -18. Those numbers are going down by 4. And they're starting at -6. So I plugged those in, simplified, I got -4x minus 2. The next one is kind of interesting because they give us the third term and the fifth term. And they tell us that it's an arithmetic sequence, so we're looking at addition or subtraction. So if you think 10 to 26, that's going up by 16. But they skipped the fourth term, so each term is going up by 8. So I worked backwards and got 2 for the second term and then -6 for the first term. So the common difference is 8. The first term is 6. Putting those together, I plugged them in and simplified, and I got 8n minus 14. And again, I'm just going to double check. Third term should be 10, and the fifth term is 26, and that works out. All right, and the last one's kind of similar to the other one they showed. We have our triangles. They're looking for a recursive formula. First term is 3, goes up by 2, so choice 4 is the correct answer.